Okay, hi Angel. So I'm going to go through number 5. So this is, it'll hit maybe some questions that you might have about and just overall how you handle data. So when I say that, you might not exactly match the book, and here I think it'll be clear after this example why you may not be exactly like what they have as their equation, and that's okay. It just depends on how you represent the data in your calculator. So if this was an assessment, like whenever I give an assessment with data, one, I'm very specific as to how you should put it into the calculator, and then is there any wiggle room? I usually have all the different possibilities on my paper, and then I would just ask that you show me what you put into your calculator, and that way whenever I'm correcting something, there are no issues. So for this one, because time is a little bit tricky, right, our time in minutes, so we're going to put 4 minutes 21 seconds points and then 7/100ths of a second. We're going to change all of that into seconds, and I think you got the gist of that through our messages. So the 261.70, the 260.91, and the 258.02. And then you would continue on, which I think you did. Now, the date is part of the tricky one. So instead of putting in years, like 1981, try to stay away from that because the calculator takes that as 1,981. It'll just produce really big numbers in your equation. So generally in statistics, what we do is we set a year, and then we consider that to be year 0. And then we would say all of the years that follow would be the number of years after that year. And so in this case, what your book does is it uses 1980, which is just a random year. You could have used 1970. You could have used 1981 because that's what your data starts with. You can use anything you want. If you want to match what their answer is, you would use 1980 as year 0, and then your data would be the number of years, your X values would be the number of years after 1980. So the first piece of data is March 28th, 1981. So we're going to put that in your list 1. Your X value is going to be 1 because 81 is 1 year after 80. And then that would get the 261.70. So when you go down your data, let's see. Yvonne Van Gennep, her time 4/16/85 is from March 19th, 1987. So her data is going to be in L1, it'll be 7, and then she'll have, 256.85? And then the one after it, Gabby Zhang, she's also 1987, so she's also going to be a 7, and X has a 7, but then her time is going to be 256.76. Okay, so you might have some double values for your X's, right? We'll have 2 7s, there's 2 1997s, and so 1997 is 17 years after 1980, so you'll have 2 17s in your list, 2 18s for 1998, and so on. Once you get those into your calculator, and I have them in mine just like you have them in yours, all right, your list 1, list 2, and then you run your regression, so you know how to do that as well. You picked up on that. You're going to run your linear regression, your LIN. You probably get something similar. I don't know if you have the R. It doesn't matter. If yours doesn't, it just means that we haven't turned it on, but that's fine. So you get those values. Now, those are very close to what your book has. They're actually a little bit slightly different. I think I'm off by 100th or something, but very, very close. So you can see we have the A is negative 1.17, so that goes in front of the X, and then the 264.16 will be the B value. So you'd write that equation. Let me erase my board. I'm doing a little different tonight because I'm at home. So we would have Y equals negative 1.144, I'll round to the 3 decimals, that's a point, X plus 264.16, right? And then you're going to put that into your Y equals screen, which I think you also got that down pat, where if you want your scatter plot to be on your screen in your calculator with your data, right, then you did that. And that should look exactly like what's in the answers in your, I don't know, I don't think they show you the scatter plot, do they? turn over my page. Yep, they do show you the scatter plot. They don't have the line, but that should look just like their scatter plot with their equation. You can see, now when you compare it, you should see you're pretty close. And then going to, I think you got all the questions for part D. It asks for Cindy Klassen earned her first world record in 2005. Okay, so if we're setting year 0 as 1980, that means 2005 would be 25 years after 1980. So now what you're going to do is take that X out and you're going to put 25 in there. So you would put negative 1.144 times 25 plus 264.16. And that will get you, again, I did it and it was pretty close. It was maybe 100th or 1,000th off, something like that. So hope that helps. If you have any question, give me a buzz. Bye-bye.